Welcome to an example about the lengths of adult males' hands. They're normally distributed with mean 191, standard deviation 7.5. So the how long is a male's hand? The average male's hand is 191 millimeters, but they're not all the same. There's the deviation 7.5 above or below that. Suppose that 15 individuals are randomly chosen. Let's give it a try. 15 people are randomly chosen. So here we go. So the first thing is they're going to say, okay, now notice this is X bar. What does that mean? Bar means average of a group of 15 in this case. It could be any number. They told us 15, right there. So we're talking about 15 individuals. So and so then this is always the mean. And this is always the standard deviation, but we have to divide by the square root of 15. That's the trick I want to help you remember. So the mean is, right there, 191. The standard deviation right there is going to be that 7.5, but you got to divide by the square root of 15, which you hit the buttons on your calculator, you'll get 1.9365. 1.9365. That's how they got that. So you have to remember that when you're dealing with a group average, not 1%. So those you're talking about, we're not talking about grabbing one man at random and saying how long is his hand or his hands. We're talking about grabbing 15 guys at random and finding the average of their hand lengths. And the average is going to be so the deviation, sorry, the standard deviation is going to be whatever the standard deviation was before for individual hands divided by the square root of the group size divided by the square root of 15. So that comes out that. So you got to remember the standard deviation changes for a group. Standard deviation changes for a group. Let me show you this in the notes. It's in the notes. It's important you know it. This can trick you on the exam. Says it well, it says it right here. Well, I didn't put it there, but anyway, it says right, standard deviation divided by square root of n. If n is more than one, this is normal distribution stuff. If n is greater than one, more than one, then standard deviation divided by square root of n. So you got to remember that when you're talking about a group, you got to do it that way. Okay, so the next question, let's go back to it. Okay, so the next question, part B. For the group of 15, so again, we're not grabbing one man at a time saying what's chance his hands are this wide or that wide. We're grabbing a group of 15, talking about the average for a group. So if we grab 15 guys, what's the probability that the average hand length for the group of 15 is more than 188? Well, you know how we do these things. Let's bring it on down here to part B. We draw a bell curve, right? Put the middle on there. What's the middle? 191, the average male hand length, 191, whatever it is, millimeters. And they're saying more than 188. So 188 would be somewhere like that's smaller than 191. And more means this way, right? So we're talking about like that, right? If it said less, we would go to the left, but more is to the right. Okay, so that's what we're talking about, right? They said more than 188, so 188 or more than 188 to the right. Okay, so then we go to our calculator. This is the low 188. This will be the high, which when it goes to the right forever, that's positive infinity. In calculator language, that's positive 6 nines. Okay, so I'm going to go to the online calculator, but remember, when I go to the online calculator, I got to use the new standard deviation because we're not talking about grabbing one man's hand and saying what's the chance his hand. We're saying for a group of 15, what's the chance that the average hand length for the group of 15 is more? So that changes the amount of deviation. You grab a group, you've grabbed 15, there's going to be less deviation, right? Like if I was to grab one person in class and talk about their hand length, and from person to person, it would vary. But if I grab 15 people and averaged their hand lengths, it would be, they'd be kind of the same. The averages, maybe you can picture maybe handling the word test scores. What if I was to grab one student say, shout out your test score. And then next, jump around. There'd be a lot of highs and lows and jump around. But if I was to grab 15 people, hey, you 15, get together, add up all your test scores and give me the average. And then you other 15, do the same thing. Well, they'd be pretty similar because when you have group average for 15, that kind of shaves off the highs and the lows and you get something in the middle. So there would be less standard deviation. That's why there's a new lower. We divided, it became much lower, right? It was 7.5, now it's only 1.9. It's much lower. There's less deviation for a group. If you're talking about a group, then it's a group average. There's less from one group of 15 to another group of 15. There's less deviation. So, all right, to the online calculator we go. Let's do it. Online calculator. Here we go. So this was, so the left is, sorry, let me just erase. This is what I had in the last problem here. Right here. Let me go back. It's probably confusing just to look at all that stuff. So come in here, you got to choose the normal probability calculator, number 8. Normal probability. Okay. The low, what was it? 188. The high was 6.9, basically infinity. The mean, what was the mean? 191, the average male hand length, 191 millimeters. Standard deviation, now we got to use the new 1.9365. So I'm not using, yeah, you got it. I beat that drum. You have got it. The P, the probability, is 0.9392. There it is. So there'd be 93% of the men, well, 93% of the groups of 15 men have a group average hand length that's 188 or bigger. So there's our first answer. Okay. So let's go back. Okay, so there's part B. There it is. Got that. Part C now. For the first, find the first quartile for the average for this sample size. For another's, same kind of thing. Let's do it. Part C, again, we're doing a bell curve, blah, blah, blah. You know how this works. Put the middle on, 191. And they want to know the first quartile, so you know how quartiles work. Right, Q1's right there. 25% right there, first quartile. So this here is the low value, which is negative infinity, so negative 6.9. This spot right here is the high value. The low, the high, which we don't know. It's blank. We're not sure. And so we go to the calculator. Just make sure you use the new stuff. Let's go there. Boom, boom. Okay, so the low is, what is it now? Negative 6.9, negative infinity, negative 6.9 in calculator language. The high, we're going to leave blank. We don't know the high. We got the mean, got the new standard. That's beautiful. Okay, so then 0.25, first quartile, 0.25 for the P. Calculate. It fills in the high. There's our answer. 189.69385. You can round to 39. There it is. There it is. That's the answer. You can see it back on the sheet. I'm going to answer the last question from the notes as we jump back, and then I'll show it to you. Go to the notebook. It says right here, where's it? Right here. Note, when n is less than 30, we must be told the data is normally distributed to use these formulas. When you have a group size less, and that's us, we have only 15. We're only grabbing a group of 15 men. So they have to tell us that it was normal bell-shaped distribution. If n was greater than 30, then it will automatically make a normal curve. So we don't even need to be told it. So let me show you what I mean. So as we go back to the question one more time. Here we are. Okay. So, there, by the way, there's our answer we just got from the Q1. Okay, now, final question. For part B, meaning when we did, group of 15, could have said part B or C. It doesn't really matter. For anything we're doing here, is the assumption that the distribution is normally necessary? We're going to say yes. Yes. Why? Because n equals 15 less than 30, we must be given or told that um, that it's normal. We must be given, let's just say it that way, save some time here. We must be given normal distribution. We must be given a normal distribution, meaning, I know it's probably confusing. You're probably thinking, whatever, I'll just do the thing. And that's all right. But I mean, you want to understand a little bit. Not everything in life is a bell curve. Not everything in life is normally distributed. And when we're using the normal calculator online, we can't do that if we don't know it's normal distributed. And of course, that's what they did. Up here, you think, well, they said it right here. They said it's normally distributed. You're right, they did. But I'm saying if and they had to, and that's what the point of this is. Because n was only 15, less than 30, yes, they had to tell us that. Is it necessary? Was it necessary? They told us, yeah, it absolutely was. Whereas if you're talking about groups 30 or more than 30, whatever, don't worry about 30 itself, just more than 30, then it'll automatically make things normal. And they don't even have to tell you it's normal in the beginning. The group averages are automatically do that. But we had 15, less than 30. So yes, we had to be told it was normally distributed. It was necessary. And so there we go.